All right, so today for 8.5, we're talking about angles and circles, and there's quite a few theorems here that we're going to be using today. That's why I wanted you to have a highlighter or some different colored pens or colored pencils or something. All right, so we're going to apply the relationships between intercepted arcs and the angles formed by intercepting tangents or secants. And we're going to find the measures of angles formed by lines that intercept arcs on a circle. The big part here, though, is making sure we remember the difference between tangent and secants. And when we look at these problems, we have to figure out what is happening. Because as we go through these theorems, you're going to be like, this is like all the same thing, just barely different. Okay? So, the first one here. The measure of an angle formed by a tangent and a secant. Okay? So if we look at the diagram over there, which one of those is the tangent? Is it BC or is it AB? The one at the bottom. Okay, so this is the tangent. Just to kind of talk about that a little bit, which means that the secant is the AB. Remember, the tangent touches the circle. The secant is the line that goes through the circle, anywhere through the circle. And so if we have the angle, so the measure of the angle formed, so we're looking at this angle, okay, is 1/2 the measure of the intercepted arc. So where is that intercepted arc?
So would it be the angle B?
So it's angle B, you could call it angle B or Q, maybe not Q, ABC. So angle ABC is 1/2 of what arc?
154.
Or 154, okay, or AC.
A to B.
Yeah, sorry, A to B. Yeah, I said AC. So this is our arc that it intercepts. And maybe I should make this line a little longer so that we can see that angle line that it intercepts, right? We're looking for that angle in there. And so you know it's 154 degrees, so 1/2 of 154, you could solve that as well. Okay. Any questions on that one? Okay, so let's go to the next one. This time, the measure of an angle formed by two secants. Okay, so where are the two secants? And this, sorry, that intersect in the interior of a circle. That's going to be important that it's interior. We're going to have an exterior as well. But my AC, DC. Okay, so I'm going to use my pink to, or no, let's see. I used the pink for the arc earlier. Okay, so these are my lines. Okay, those are my two secants. And so it intersects on the interior, and we're looking for 1/2 the sum, oh, that's funny, of the measures of the intercepted arcs. Sum means to do what? Add them, okay. So my intercepted arcs are AB and DC here. So this one's going to be like angle 1 is going to equal 1/2 the sum, so I need parentheses, of arc AB. What's sum mean again? Addition, plus the arc of DC. AB plus DC. Does that make sense? Okay, so what can you tell me about, so that was for angle 1 right here. What can you tell me about this angle over here? The one over here. Is it, we could call it angle 2. It's not labeled angle 2. But this one was angle 1, this angle in here. Why are they congruent?
Because they're the exact same.
Take it back, take it back. What's the name of them?
They exact.
What's the they're vertical angles. Yes. Okay. So they would be congruent because they're vertical. Nice. So it doesn't matter if you did angle 1 or the other one. They're both going to be the same because it goes back to that vertical angle here.
They were congruent just because their equation would be the exact same.
Gotcha. Okay. Their equation would be the exact same, but like taking it back to like what we know and why we know it. Okay. Next up, the measure of an angle formed by two secants. So we've got two secants again that intersect exterior of the circle. So this time the point of intersection is out here. So there's our secants. It's a line that goes through the circle, but their point of intersection is exterior to the circle. And this time it's 1/2 the difference of the measures of the intercepted arcs. Okay, so Lucas, give me the equation for that angle 1. Here, whoops. Right, so we're looking for the arcs that this intercepts. So it's 1/2 the difference of the intercepted arcs.
So it would be CE.
So 1/2.
Yeah, 1/2 CE plus
The difference. Difference means subtraction.
But why do you know to put that arc first?
Because if you look at them, CE is the larger arc.
So you just automatically want to put the larger arc?
Yes. Yep. So you put the larger arc. Good question. CE minus, I'm sorry, Lucas, he kind of cut you off.
BD.
Minus arc BD. Good. Perfect. Are we ready for the next one? Okay, this time we have the angle formed by a secant and a tangent again. That was just like the first one we did, right? This time it intersects at the exterior. Oh, remember the one up here was at the point of tangency. We didn't underline that. This time we have an exterior intersection. So our secant is the one that goes through the circle. The tangent has a point of tangency on the circle, and our point of intersection is exterior. So the circle, let's see, is 1/2 the difference again of the measures of the intercepted arcs. All right, so the intercepted arcs this time are BG and
No, it'd be BA.
pardon me, BA, thank you, and AE.
So BA minus AE.
Right. So this time it's going to equal 1/2. What'd you say?
BA minus EA. Or AE.
BA. Yes. Arc BA minus arc EA. You got it. And are we ready for the last one?
Yep.
Okay, so this time it's the measure of an angle formed by the intersection of two tangents. Okay, so the tangent lines are the ones that just touch the outside of your circle. They don't go through your circle. So it's 1/2 the difference of the measures of the intercepted arcs. So the equations are so similar, but slightly different. Okay, so then this time, right, there's one arc, and maybe I should, that's the thing, like maybe I should use another arc color. Maybe I should have done that up here too. Right, where the arcs meet at the point of tangency. All right, so Justice, give me the equation for this one.
Equals 1/2 and then CA.
Okay, CA is your smaller arc.
So not
Because it could be CA, but remember if we're using a bigger one, so that's where it gets a little tricky.
BA.
Yes, let's call it. So arc CBA, so we know it's the major arc minus arc CA. Okay, So yeah, that way we get the major arc. We remember like, okay, it's the big one minus the small one. Now, this chart down here is going to be super helpful for you to remember which ones are which. Okay, so all you have to know is your angle vertex location. So where is the vertex? If the vertex is inside the circle, interior, okay, that's the only one we had, or is interior, then it's half the sum. Inside, we sum it up. We add them together. If it is on the circle, it's just half the measure. So this one was on the circle, and it's just half, right? In the circle, it's half and a sum. Every single time that it is outside the circle, so your point of intersection is outside the circle, it's always a half minus, right? Or it's a half and the difference of the arcs, right? All of these are a half and then you subtract. So maybe that will help you remember. If you can find your point of intersection, then maybe you can remember. If it's exterior, you always subtract. Interior, you like the colors? Good. If it's interior, you add them, and if it's on the circle, it's just half. That is something that's helpful for me to remember which ones are which. Okay, so we have 3 problems actually to solve these, so let's get into it. All right, so example 1. Find the measure of angle WYZ if line XZ is tangent to circle Q at Y. So what am I finding? What angle? Okay, so we want WYZ. So I want this angle through here. Nope, WYZ. I did WYX. Good job. Okay, so I want that angle right there.
So it equals
So first of all, where does it lie on the circle?
interior.
Is that interior to the circle? This point of intersection?
No, it's on the circle.
It's on the circle. Okay, so if I go back to this chart up here on the circle, it's just half the measure of the intercepted arc.
Sorry, I thought you asked what the angle was.
That's okay. So right, so the measure of angle WYZ is going to equal half of arc WZ. I wrote it in. My goodness. It's half of WZ, right? Arc WZ. And it doesn't have another variable or another letter on it, so I can't name it. Is it WZ?
What? It's arc WY.
Aha, there you go. It's arc WY.
You not be risking with that today. I'm writing pen.
Okay, I'm sorry. I won't do it anymore. I'll try not to mess you up anymore. All right, so then this equals 1/2. And what is the arc WY? 240. So it equals 120 degrees.
Next.
She's still on his phone.
Why? Why are you so
I was just looking at it. Can I just look at it?
No.
Okay, I'm sorry. My bad. So 120 it is. Then let's go on to the next one. Well, let me ask you this question. What would WX be? Or arc WYX? What would the measure of angle WYX be? Can you figure that one out?
Can you dig it?
Yeah.
60.
How do you get 60?
Because that arc is 120.
Okay, so this arc would be 120. So the angle would be 60. Anybody think of a different reason why? Because I'm going to write 1/2 of 120.
Yeah, because it's still a generator. It's still on the line.
But anybody have any other reason why?
Is it correct?
It is correct. Yeah, 60 is right. I'm just saying, does anybody have a different reasoning why? Okay, we can, just to point it out, this is a straight line, right? And if this angle is 120, what does this angle have to equal? 60 because it's 180 because they're complementary angles, or supplementary angles.
Wow.
Yes. So see, there's like, you have all this wealth of knowledge now that we learned in like first semester, and we can pull it all together or use it in different ways. All right, so example 2, we want to find the measure of angle 1. Okay, so the measure of angle 1 is right here.
Wouldn't it just be half of the
No.
It's a good question.
this is asking for the measure?
Yeah, there's 2 seconds.
Okay, so that's
Oh,
it.
yeah.
It's the intersection of 2 secants. Okay, so if we keep this, maybe we should extend these, right? So like we're looking at that intersection, but we're looking at this angle. Okay, so it's got an interior or an exterior intersection? Interior, so do we add or subtract those arcs? What was it? Add. Yep, so my arc is what? 85 degrees, so that JK. So it's going to be 1/2 of 85 plus, because you said we add. And what is, oh, that's our other arc, right? Isn't that other arc for the intersection?
Do you have a decimal on this?
Yes. So how are we going to find the arc measure for LM? Yeah.
You add all the other arcs since you know them all.
I can add all the other arcs since I know them all. Okay, 85 plus 45 plus 120.
Is that 230? Or no, 250.
250. Okay, so this is 250 degrees.
And then you subtract it by 360, which equals 110.
Nice. So that's kind of your intermediate answer that yes. And this was for arc LM, right? So the measure of arc LM is 110 degrees. Nice job. So the measure of angle 1 equals 1/2 of 85 plus 110. So that's 1/2 of, what is 85 plus 110? 195. And so what's 1/2 of 195?
Is it 97.5?
It is 97.5. You're welcome. You got it. So 97.5. Sorry, I usually put a box around our answer. So the measure of angle 1 is 97.5 degrees. Perfect. That is beautiful. Okay. Example 3. You guys did awesome with these. All right, so we have a couple things to find on this one. All right, we're finding the measure of angle YXZ, the measure of arc WY, and the measure of arc WV, if the measure of angle WXZ equals 40. So let's see, so W to X to Z. So this whole thing here is 40 degrees. Okay. So what do we want to start with? Do we want to look at let's see, YZ or YXZ?
Would you do WY since you have both? No, because you don't have WV. Because you have Z, V, and YZ.
Right. Because it's asking for this angle, right? Y to X to Z. So you know the whole thing is 40. So how are we going to figure out that one little piece? So first of all, what is
What would you do half of
okay? So we have to think about it. What is making this angle? Is it two secants, a secant, and a tangent? What is it? Do what? It's a secant and a tangent. Okay. Is it the point of intersection? So the vertex. Is it interior on the circle or exterior? Exterior. Okay. So if it's exterior, we know that it's subtraction. Okay. So the measure of angle y, x, z equals 1/2. And we have to subtract these.
So would it be 88 subtract
The big number always goes first.
145?
What does that say?
The measure of angle y, x, z. Yeah.
We get a decimal on this one too.
Mm-hmm. All right, so that equals 1/2. What's 145 minus 88?
Is it 57?
Yes. Okay, and so what's 1/2 of 57? Hold on, it's not 50. Yeah, I think it is. I was like, I didn't do the intermediate step. I just put it all in the calculator. So yeah, 1/2 of 57. 28.5. All right. So 28.5 degrees is one of our answers. So this one angle is 28.5 degrees. So here's a question. From that, could you figure out this other little angle?
Yes.
Yes.
11.5.
It's 11.5. How'd you get it?
Because the whole thing is 40.
40. So
you do
40.
minus 28.5 and you get 11.5.
Okay. So that might be helpful too to know like this one's 11.5. Okay. So we've got the first one done.
So when you find the arcs, can you do it where you do 11.5 equals 2 times something? Like, I don't think I'm going to be doing this whole equation, but could you do 11.5 times 2, and then you distribute that to the two arcs by knowing what the other arcs
So you're saying take the quantity 11.5 times 2 to get 23 and have 23 equals the difference of the others?
Mm-hmm.
Yes. But we want to set like, because
it's easier just to add the, well, no, never mind.
okay.
I'll just wait.
This one, okay, so this one is tougher because we are going to have to do substitution or elimination in order to solve it. So let's think about like the measure of arc. This is why I, again, encourage you to write equations out for your things so you can do some thinking. So let's go to, next up is the measure of arc WY. Well, what is the measure of arc WY? It's A. Okay. It's A degrees. Any other way we could kind of get that?
Would it be
You can keep thinking on it. So we're like, okay, well, maybe we're kind of stuck here. Let's think about the measure of arc WV. There's nothing there, right? So, I mean, like, what about if we look at the whole circle? Well, the whole circle equals 360, and we know this is 88, right? Yeah. Sorry, I had to check because the handwriting or the type is so messed up here. So 88 and 145 in A. So we could say, well, WV is the same thing as if we take the circle, the 360, and we subtract the 88, we subtract the 145, and we subtract A. Okay. It doesn't get us much further, but it is something, right? Sometimes we're just like drawing straws here. Okay. So that equals, what is 360 minus 88 minus 145? Justice, what is that? I believe you. Try again. 360 minus 88 minus 145.
Oh, I did what, 44?
You just, oh, okay.
Make 145.
That's what I meant.
That's what you meant. Okay. So now we've got the measure of arc WV. My goodness, I have like backwards problems today. Is 27 minus A. Okay. Thank you. 127 minus A. Well, all right. What else do you think?
Would you
Put in a random number.
use
Well, how can you link these things?
11.5?
What was that again?
Do you do something with the 11.5?
We possibly could do something with the 11.5. Yeah. Why do you say that?
Because it's the angle
Because it's the angle that what?
that both arcs share.
Yeah, it's the angle that both arcs share. So
Would it be 3 equals A?
So
plus-
angle, like to get these two things together, kind of, Lucas is saying, well, hey, they share this they share this angle. Okay, so the measure of angle WXY, right, would have to equal, what's the formula for this angle? It's a secant and a tangent. The point of intersection is exterior, so it's going to be equals 1/2.
Arc minus arc.
Okay, which arc?
No,
Arc.
arc WY.
Okay, the measure of arc WY minus the measure of arc WV. Perfect. Okay, so we know the mark or the angle of WY is A. So now comes that. We're going to substitute it in.
So it'd be
And we know the
A
measure of
minus
WV
127.
is this. Well, so we're going to have this equals 1/2 A, right? WY is A minus the quantity, good, 127 minus A. And then we have to close it.
Double close.
Yeah, it's like a double close. That is the hardest part about this problem right there, is realizing like, okay, well, I'm stuck at A. I'm stuck at 127 minus A. Now how do I bring those two things together? Because now you suddenly have one variable. You do not cancel out the A's because we have to solve for A, right? So we need to leave the 1/2 and do the stuff inside first. So this is going to be,
1/2 and put it on the other side. By dividing, which would be multiplying by 2.
you could, but we want to know the measure of this angle, so it wouldn't do us any good.
But we already know the measure of the angle.
Oh, I forgot we do know the measure of WXY. We should have put that in there. I don't know. It was 11.5, right?
Yep.
Okay, so yes, we could. Would you guys rather do that? Go ahead and multiply by the 2 to get rid of that?
Sure.
Okay, so to get rid of the 1/2, we're going to multiply by 2. So then we have 23 equals A.
Minus the quantity of 1.7.
Nope, let's get rid of the quantity part. Like we don't need the quantity. We can work around that if we distribute. That's why we have the distributive law, is it gets rid of our parentheses. So what do we distribute in this case?
The minus sign.
The minus, just the minus, because this is, so we subtract 127. What's a negative times a negative A? Ah, that's why we don't cancel. Good. Okay, so we're still trying to solve for A and get A by itself.
So, would you add 27?
Yes, I would. I would add 127. So then I would get 150 equals what?
Equals A squared.
Nope. A plus A is not A squared.
2A.
A plus A is 2A. Then what would we do?
Then you divide the 2.
Divide by 2. So A equals what? 75 degrees. So that's our, again, kind of an intermediate answer. No?
We found one of the arcs.
We found one of the arcs, right? The measure of arc WY was A, so it's 75 degrees. So check.
Would you take 75 minus 127?
Yeah, and then we can do this one. We can say, well, the measure of arc, not angle. Okay, forget it. The measure of arc WV is 127 minus 75, which is
Is it 52?
it is 52 degrees. Beautiful. So now not only are we pulling from other stuff, like earlier we talked about their vertical angles, but we're pulling from algebra and using like systems of equations to solve. Hey, you guys been doing real math all day today. What are you talking about? Distributing and equations and all the things.
Did you hear what Justice said?
What was that?